taking the idea of shielding effect and effective nuclear charge, we can show different ionization energy values of different elements in different periods and groups in graphs. Okay, so by taking the above facts into consideration, we can construct a graph to show the variation in first ionization energy of the first 20 elements in the periodic table. Anyway, we can also see a slight deviation in this pattern of first ionization energy variation from what we have discussed so far. Okay, even though I give some explanation, when it comes to this lesson, you will see some differences also. It's not worthy to mention that this deviation pattern appears periodically in all the periods as shown in the following graph. You may not understand this very well. Let me first construct the variation in first ionization energy from lithium to, let me take, yeah. I will discuss the first ionization variation for lithium to neon. Lithium is group 1. Sodium, neon is group 8. So 1, 2, 3, 4, 5, 6, 7, 8. What I told earlier was when you go from group 1 to group 8, first ionization energy increases. Yes. So first I can write, if the first ionization energy of lithium is here, first ionization of neon should be somewhere here. But I will not draw a straight line because I said there are some deviations. What are these deviations? We will talk about it in detail now. We'll see how this variation occurs. Here I have shown how the first ionization energy variation occurs from lithium to neon. But you can see for boron and for oxygen, I have not shown a value. It is because for boron, the value comes down a little bit from beryllium. Lithium to beryllium, it increases. And from beryllium to carbon, it doesn't increase in a straight line. It comes down a little bit. But you don't draw it as low as this, and then you go up, further up. From nitrogen, again, you come down a little bit, but not as low as nitrogen. And then from here, you go up to fluorine and fluorine to neon. See this pattern? Is it increasing continuously? No, it shows a gradual increase. But from group 2 to group 3, it comes down. Group 5 to group 6 also, it comes down. Okay, do you remember now that I told when you go down the group, ionization energy decreases. Down the group, ionization energy decreases. Why do I remind you this again? Because when I go to the next one, this is group period 1. This is period 1. When you go from period 1 to period, this is period 2. When you go from period 2 to next one, period 3. Period 3. Period 2, first element is lithium. Period 3, first element is sodium. From lithium to sodium, definitely when you go down, the first ionization energy has to go down. So if I mark the first ionization energy for sodium, it should be something lesser than lithium. So I draw a dot over here. Not only that, when you go from neon to argon also, first ionization energy has to go down. So here, if you go to argon, argon first ionization, it should be lesser than the first ionization energy for neon, because down the group, first ionization energy decreases. But here I have a sentence. It's not further to mention that this deviation pattern, okay, this deviation pattern in first ionization energy appears periodically in all the periods as shown in the following graph. It means this pattern from group 1 to group 2, it goes up. Group 2 to 3, it comes down. 3 to 4 goes up. 4 to 5 up. 5 to 6 down. 6 to 7 up. 7 to 8 up. Same pattern should be drawn here also. But all the values will be lesser. So here I can draw from sodium to argon. Probably I can use a different color. This is where sodium starts. Sodium to magnesium, you move up. Magnesium to aluminum, you come down. Aluminum to silicon, you go up. Same pattern. Silicon to phosphorus, you move up again. Phosphorus to sulfur, come down. Sulfur to argon, you go up. And argon, no, aluminum, no, this is wrong. This should be chlorine. From chlorine to argon, you go up again. Now, what do you think about potassium and calcium? Potassium is group 1. When you go down, the ionization energy has to decrease. So lithium over here, sodium over here, potassium should be lesser than for sodium. From potassium, again, you go up to calcium. Again, I can use a different color for this. Now I go backwards. Now helium. Helium is above neon in the periodic table. So helium first ionization energy should be greater than neon. So I will draw somewhere here for helium. And hydrogen is somewhere here. This diagram comes in exams as it is. Oh. In the meantime, I will show up here helium. This is neon. This is argon. And down here, even though everything is shown on the x-axis for better understanding, I'll write sodium here. Lithium, sorry. Lithium comes first. Lithium here. Sodium here. And potassium here. If you go further down, this trend will still go to a lower value. The level will go down. Always remember, in a single period, the lowermost energy level is experienced or observed for the first group, and highest first ionization energy will be seen for the group A. Again, you start at a very low value, go to the peak, again come down to a very low value, and likewise this pattern changes. Always remember that in a diagram, in a graph, maybe you don't get always this complete diagram. At times, one small part is given, something like this. You have to analyze. If a diagram comes like that, what you must see is this part. It's the most important part. You are coming from a high value to a very low value. This one always shows that you are coming down from a group 8 to group 1. This information is necessary. Yeah, your observation power is superb. No, actually, I copied this from some other work I was doing. You don't have to have positive or negative charge for these symbols. Sodium, just oxygen, just. The problem is only with oxygen and nitrogen. Yeah, now it's okay. You can't have any charges over here. They should be just neutral atoms. You are supposed to know this very well. The pattern, the relative positions, everything. So have a good look at it and try to find a way to remember.